Algebra lesson 8-4. Now that we've spent some quality time dealing with exponents, we're going to talk, and we've realized that with those exponents, sometimes you have very large or very small numbers. We're going to look at a way to deal with some of those very large and very small numbers. One of the fields that probably comes across these numbers the most would be science. Science is dealing with astronomically large numbers when they're dealing with space. They're also dealing with very small values when they're dealing with microbes and atoms and things that are very small looking through a microscope. So we have a concept, what we call scientific notation. And scientific notation is where we will have a number, we're just referring to that number as a C value, that gets multiplied by a 10 to a certain power. And yes, it is always a 10. It'll never be an 8 here, it'll never be a negative number, it will always be a 10. Now the power can change, and this number can change, but what's very important about C, what's important about the number you choose, is it can be a 1, but it can't be smaller than 1. And it can't actually become 10. In other words, it can't become a 2-digit number. So it must be as a bare minimum a 1, 1.0. It can be 1.1, it can be 1.2, it can be 2.7, it can be 5.8, but it can't become a 2-digit number, and it can't be less than 1. So that's a range that it must be between. All right? So n is an integer. You can't have any decimals for your exponents. And there must be exactly one number left of the decimal. And that's what makes it fit between at least a 1 but not becoming a 2-digit number. There must be exactly one number left of the decimal. And that can't be a 2-digit number otherwise. Now, these are some examples of scientific notation. You'll notice it's times 10 because it's always times 10. It's got an exponent that is not a decimal. And there's exactly one number left of the decimal. And 4.2 would fall between being a 1 or greater and smaller than a 10. Now over here, you have a negative 3. That's okay for that. It just can't have a decimal. And it doesn't matter how many numbers are to the right. It makes no difference how many numbers are to the right of the decimal, but there must be exactly one number left of the decimal. 5.37896 is still in between that 1 and 10. These are the same values. I just moved the decimals on them and changed the exponents. You'll notice this is now 42 point. You can't have that. There's 2 numbers left of the decimal. That's not allowed. Here's 537.896. That also is not allowed because there's more than one number left of the decimal. So you must be careful about that. Now, here are some other numbers. 3.096 times 10 to the third. And if you wanted to convert it back into just a regular old number, what we would do is we would take this 3 tells us how many places to move this decimal to the right. So you would move it to the right 3 places, which makes 3096. So 3.096 times 10 to the third. 10 to the third is actually a 1 with 3 zeros, or in other words, 1,000. If you took 3 and multiplied it by 1,000, you'd have at least 3,000. If you take 3.096 and multiply it by 1,000, you have 3,096. Now, if it's a negative number, then the decimal is not going to go to the right. The decimal is going to go to the left. And it's going to go to the left 4 places. So I'm going to move it 1, 2, 3, 4 places. So the new decimal is right here. But I've got all these unknown values. I have to put zeros in them. So our final answer would be 0.0004087. In other words, a fairly small number. But I can't deal with that number when it's so small. So that's why changing it to scientific notation is so helpful. All right, if we want to go the other way, currently the decimal on 4096 is all the way to the end. If you don't see a decimal, it's always at the end of the values. We would like it to be here because you need to have only one number left of the decimal, which means this is going to have to move once, twice, 3 times. Now this is the part where people make mistakes. Because they look up here and they go, oh, I moved it to the left, it must be a negative. But remember, we're not going from scientific notation to a standard number anymore. We're going from standard form back to scientific notation. So it's actually opposite of that kind of idea. So this is actually going to make 4.096 times 10 to the positive third. 4.096 times 10 to the positive third. Remember, when you saw 3.096 to the 10 times 10 to the third, we moved it to the right. because 10 to the third is 1,000. So this 10 to the third is 1,000. If you took 4 and multiplied it by 1,000, you'd have 4,000. So it makes more sense that it would fit that way. Right down here, we would like the decimal eventually to end up here, because all these zeros won't be there, and you must have exactly one number left of the decimal. So that's 1, 2, 3, 4, 5 moves. It moved 5 places to the right. Now this is a very small number. The very small numbers always have a negative exponent. Remember? The negative exponent up here produced a very small number. So this is actually going to become 7.89 times 10 to the negative 1, 2, 3, 4, 5. Now that's hard to remember all these rules, which is why I've actually kind of made them up here for you. Rules regarding scientific notation. If you are in scientific notation to begin with, and you would like it converted into a regular number, which we call standard form, and you have a positive exponent, you are going to move the decimal to the right, however many numbers are in your exponent. If you have a negative exponent, and you're in scientific notation, then you're going to move the decimal to the left. Alright? If you are a regular number, but you would like to create scientific notation, in order to move the decimal to its proper new location, if you move the decimal left, your exponent will be positive. So if you have a large number, and the decimal's all the way over here at the right, and you need to move it to the left so there's exactly one number left, you're moving the decimal left, that means your exponent will be a positive. If you move it to the right, then your exponent is going to be negative, because you're actually dealing with a small number that you're now converting into scientific notation, the decimal moving right. So those are your two situations. Let's apply these rules. Now, we have a multiplication problem here. And this sometimes bugs people because they're not quite sure what to do. It's multiplication in the middle. It's also multiplication right here, and it's multiplication right here. So in reality, the whole problem is multiplication. You can multiply in any order you want. So you will take 2.5, and you will multiply it by 5.8. And 10 to the fourth is being multiplied by 10 to the second. And since you've already learned what to do with multiplication when they have the same base, you're going to add these exponents together, and that's going to make 10 to the sixth. When you multiply 2.5 times 5.8, we take a calculator. This is not going to give us perfect decimals. 2.5 times 5.8, we get 14.5. Now, 14.5 times 10 to the sixth is not an acceptable answer. And the reason? You can't have two numbers to the left of the decimal. So what we need to do is move the decimal one more place to the left. Now remember, we're creating scientific notation. So if we're creating scientific notation and we move the decimal left, it's going to add more exponents. So as I move this decimal to the left, make it here, I'm going to get 1.45 times 10 to the 7th power. And the reason, I had to move it one more place to the left so it adds on another positive exponent. Alright, now there's division. Don't worry, it's okay. You're going to take 1.82 and divide it by 1.4. That's no different. 1.82 divided by 1.4 gives us 1.3. And you're going to do 10 to the negative first divided by 10 to the negative third. Well, if they have the same base, you subtract those exponents. So that makes 10 to the negative first minus negative 3, which we know becomes plus positive, so we end up with 10 to the second power. So you put that 10 to the second power with this 1.3, and you have 1.3 times 10 to the second power. And that is an acceptable answer. I don't have to adjust it at all because it already has one number left of the decimal. So again, when you're in these situations, go ahead and take the numbers that are in the front and do the division or the multiplication and deal with the exponents on the base number of 10 the same way we've already been dealing. One more example. Now this one is a power of a power on the beginning here, and we are going to give the 1.4 also its own. So we have 1.4 to the third and we have 10 to the negative 4 to the third. We know that when it's power of a power, we're supposed to multiply. Now 1.4 cubed, that gives us 2.744 times 10 to the negative 12 power. Now if we check it, there's exactly one number left of the decimal, so this is an acceptable form of scientific notation.